For 6, we're going to graph other trig functions, and by other trig functions, I mean specifically cosecant, secant, which we're going to talk about here at the beginning. Think about this. They're reciprocals to sine and cosine, so they're related to those graphs that we already know how to do. Okay, we're going to see a new shape appear. Okay, and after we do cosecant and secant, then we're going to look at tangent. And tangent has a couple of things that are different than all of the other trig functions, which is why we haven't graphed a tangent yet. Okay, so cosecant function, we are going to graph in this frame, we are going to graph y equals cosecant x. So that's kind of like when we graphed on the very first day of 4-5 when we just did like the regular sine x and cosine x. So it's kind of like the parent graph. Okay. So if you think about it, cosecant x, it has an a, b, c, and d value. What's a? 1. What's b? 1. What's c and d? 0. Okay. So in the graph, because we know the values of a, b, c, and d, we can say for this particular graph, the starting point is at 0, 0. Or not for the graph, but for the frame, I should say, because I'm building a frame again. And we said that the a value was 1, so remember you would go to your y coordinate and you would add 1 and subtract 1, so like the highest and the lowest parts of that frame are 1 and -1. Okay, now cosecant is the reciprocal to which trig function? Sine. Okay, it's the reciprocal to sine. So when you're thinking about a possible period for this function, it's probably the same as what happened with sine, right? How long it took for it to repeat itself. Okay, so for period, we're going to do the same thing for cosecant and secant, 2 pi over b. And Olivia told me the b value is 1, so its period is 2 pi again. Now it's going to change with tangent, FYI, be aware. So then I start at 0, I go all the way to 2 pi, cut that in half, in the middle is pi, and then I would have pi halves and 3 pi halves. Okay, now what we did with the sine function was I actually had picked values of theta. I chose those angles that we see at the bottom, 0, pi halves, pi, 3 pi halves, and 2 pi, and we plugged them into sine, and then we went around the unit circle, right? So when we did like sine of 0, the y coordinate at the angle 0 is 0, so sine of 0 is 0. And then when we did pi halves, the sine of pi halves is 1, because at 90 degrees your ordered pair is 0, 1. So we're basically going to do the same thing, but we're going to talk about cosecant as the reciprocal to sine. So cosecant, being the reciprocal of sine, means you're really just doing 1 over sine. Okay. So what I'm going to do to help me get ordered pairs for cosecant is I'm going to lightly sketch the sine function in this frame. So I'm going to use my green marker and I'm going to make it dotted. This is not cosecant, this is sine. I'm going to lightly sketch sine, which is mountain high and valley low. So there's y equals sine x. And we had these points, like this starting point is 0, 0. So at angle 0, the sine was 0. If I do the reciprocal of that, I'm doing 1 divided by 0, which is undefined. Okay, so that now causes a problem. If we're doing cosecant, the cosecant of 0 is undefined. that means there is no graph right there. We're going to have an asymptote. When this is a vertical asymptote, so it's going to look like x equals 0. Now, when I move to the next point that we put in the table for sine, which was pi over 2, I just picked all the quadrantal angles because they were really easy. When I put pi over 2 into the sine function, we got out 1, right? That's at 90 degrees. Well, if I'm doing cosecant of pi over 2, I want to do the reciprocal of that value. What's the reciprocal of 1? 1. 1 over 1 is 1. So that point, pi over 2, 1, that's a point on the sine graph. It's also a point on the cosecant graph. So they share that point. Now at our next point, we're at that 180 or pi angle. And when we put pi into sine, we get out 0. So we're back at this midline of our graph. Well, we already know what's going to happen whenever sine is equal to 0. When I do the reciprocal, it's going to be undefined again and produce another asymptote. So I also have an asymptote at x equals pi. Can you tell me where my other asymptote is? 2 pi. Okay. So I use this idea to help me with my cosecant and secant graphs. Wherever your graph is crossing this midline, that's where your sine or cosine would equal 0, which means that the reciprocal secant or cosecant is going to be undefined, and that's where your asymptotes are. So you know where your asymptotes are going to be. There's one point I skipped over, 3 pi halves, and that gives me a sine value of -1. Well, the reciprocal of -1 is also -1. So just like up here at this max point, the top of my mountain, at the bottom of my valley, that's a point those two graphs share. Because the reciprocal of 1 is 1, and the reciprocal of -1 is -1. So this is also a point on my cosecant graph. Okay, well this is really strange, because it's not at all like the wave that I saw before in section 4.5. And now I've got 2 points that are separated by all of these asymptotes. So this one time, I'm going to do some extra points, and that will help us see what the shape of cosecant and secant would be. But in the future, these are the only things you need to graph. Well, like you'll draw the rest of the shape, but you'll know what the shape should be. So you'll have asymptotes, you'll have these max or min points, and then you'll draw the rest of the shape. Okay. So I'm going to get some extra points for my graph, and I'm going to pick some angles. Actually, I'm going to move this thing so I have a little more space. I'm going to pick some angles. I'm going to make like a table of value. And I'm going to do like a sine, and then I'm going to do a cosecant, because we're just going to flip the sine value to get our cosecant value. I'm going to pick something that's really nice to do cosecant. So I'm going to pick pi over 6. What's the sine value from the unit circle at pi over 6? 1/2. Therefore, the cosecant is 2. So if I plot pi over 6, comma 2, that would be less than pi halves, and I would go up 2. That's a point on cosecant. And I'm going to pick another point that's pretty easy. I'm going to pick 5 pi 6. What's the sine of 5 6 pi? Positive 1/2. It's over in quadrant 2, isn't it? And you go up 1/2. So then it also has a cosecant of 2. So then 5 pi 6 is less than 1 pi, right? 5 6 is less than 1. So somewhere over here, then I'm going up to, what shape do you think you might use to connect those 3 points?
Parabola.
Yes, it's a U shape. It's not technically a parabola, because parabolas like go out They're not trapped by two vertical asymptotes, so it's not technically a parabola, but it's a U shape. You guys don't know really truly about parabolas until we do conic sections later. Like what is really a parabola versus a U. But we'll get there.
Isn't that out of the amplitude though? Like how would we do that?
Yeah, so you'll draw the frame, but in cosecant and secant, your U's will be outside the frame. So they won't actually be in this section. This section is no cosecant or secant. What do you suppose you might do here at 3 pi halves negative 1?
Upside down.
An upside down U.
So
I knew that was down. Because then we're going to have y values that are negative 1/2, which are going to be reciprocals to negative 2, so those are going to be lower. So Kinsey's right. Like you're not actually drawing inside the frame, but we'll still draw that rectangle, and then your U's are going to be on top and bottom of your rectangle. Okay. So notice I always extend my asymptotes beyond my frame. Okay, so off to the side I have this like be sure to label. So just like on that quiz that I handed back to you, there's things you need to be able to do with sine and cosine. There's things that you should be able to answer for me about cosecant and secant, and they include period. Well, we already did the period for this parent graph, and I hadn't kind of like led you along. Since it's the reciprocal to sine, we would assume it works the same way for period, right? So period is still going to be 2 pi over b. It can be larger or smaller than 2 pi if your b value changes it. For starting point, we still used c over b comma d. It just so happened that for cosecant x, c and d were 0, so this is going to be c over b comma d. You should be able to label the range. I would say on this one, I'll do the range after I see my frame or my graph, because then I can kind of see what's happening. So if I want to do the range for this graph, cosecant x, think about it in the picture. What's the lowest point of this graph? Yeah, what is it? Negative infinity. And then I come up all the way to what value? Negative 1. Should I include negative 1 or exclude negative 1? Include, so it's going to be a bracket. So negative infinity to negative 1. You can think about that like that's the range of the lower u, or the u that opens down. And then there's some open space in the middle of my frame where no cosecant points will be graphed. And then I start back up again at 1. So 1 to infinity. So this is like the range of my u that opens up. Okay, so we say in union with 1 to infinity. Now, of course, those values can change just like the ranges changed when you did different amplitudes and starting points for sine and cosine, right? If we shift our graph up, that would change the values that are in the range. If we have a stretch or a shrink, that would change the values that are in the range. So I got my range done. You should be able to list asymptotes. I always list the asymptotes as I go. X equals 0, x equals pi, x equals 2 pi. Make sure that you have an x equals. Think back to like rational functions in chapter 2, semester 1. Horizontal and vertical asymptotes need to be written as equations of lines. That's what they are, lines. And then the points, the only points that you need to label are the like mins and maxes of the u's. So like these extra points that I use to get the shape of the u, you don't actually have to graph those extra points. You know it's always going to be a u. So you just need that lowest or highest point on the u. What things am I not asking you to find? Domain. Why am I not asking you to find domain? There's a lot of asymptotes, and they're just going to keep repeating, right? Your next asymptote is at 3 pi, 4 pi, 5 pi, 6 pi, etc. So there is a way to write domain. It's like basically saying accept all of these multiples of pi, but I'm not going to have you do that. It's already a lot what I'm giving you today, so I'm only going to ask you to name ranges. Is there something else I'm not asking you about specifically? Amplitude. Okay. Notice that we use A to build our frame, just the same way we used A in section 4.5. But amplitude is defined as half the distance from the min to the max. Well, if my min is negative infinity, my max is positive infinity, there is no half the distance. So amplitude only is describing waves, so we don't call it amplitude anymore. Okay. All right, let's see cosecant. Or sorry, we already did cosecant. Let's see secant. I'm going to do less work for this one, but essentially I'm doing the same thing. The starting point will be a 0, 0. This is the reciprocal to cosine, so the period is 2 pi over 1, which is 2 pi. I can then build my frame. They're in passing period.
There should be some.
So the frame is the same because this is off of the parent graph of cosine, right? I'm going to draw or sketch very lightly cosine. Now, I will say this. I don't memorize the shapes of sine or of cosecant and secant. I just always lightly draw my sine or cosine, and then that tells me where my u's are going to be, where my asymptotes are going to be. That seems easier to me because I'm really good at sines and cosines. If you want to memorize the u shapes, you can, but I just like to go off of the reciprocal function. So by lightly sketching cosine, that's this green one, I'll draw it, y equals cosine x. By lightly sketching cosine, I immediately know where my asymptotes are. The asymptotes will happen for any place where cosine crosses this midline of the frame, because at the midline of the frame, cosine equals 0. And the reciprocal of 0 is undefined. So this time I have asymptotes at x equals pi halves and x equals 3 pi halves. And then the other thing I like is by sketching the sine or cosine, I immediately also know where my u's are. So like every time you're at the max of your frame, that's a shared point with a u that opens up. Every time you're at the minimum point of your frame, that's a shared point with a u that opens down. Because of the shape of cosine, I start right there at 0, 1. And then, technically, I only have, the right half of that u. The left half of that u is from another period or cycle. If you draw the full u over there, that doesn't bother me. Okay. And then at pi negative 1, so I'm labeling my points as I go, I have a u that opens down. And at 2 pi 1, I have a u that opens up. Of course, this one again is only half because I don't get that full mountain. The reason why I only draw the half u's is could you imagine taking a tool on the computer and just cutting out just the edges of this frame? Okay? And then if you copy it, then this u finishes the last u. Okay, so that's one cycle. And this graph, of course, will have the similar range because we haven't changed vertical shifting or a values, so it's going to be negative infinity to negative 1 in union with 1 to infinity. So if you lightly sketch sine and cosine, if you draw it as a dotted line and then you do cosecant and secant, that's fine with me. If you want to erase it after you're done, that's okay. Whatever works for you. Does anybody have any questions so far? Okay, let's do one with A, B, C, D changes.
These are hard.
The hardest part, I think, like after you get the hang of it, should be building the frame again. Like that was the hardest part about sine and cosine, and that should really be the hardest part about cosecant and secant. So to me, I always work with the information that I need for the frame. That's where I like start my work. So we have y equals negative 2 cosecant x minus pi over 4. Now, remember when we started with sine and cosine, we were doing amplitude, period, and starting point? I would do that thing where I would write like y equals a, in this case, cosecant bx minus c, and then there's a plus d. So if you're ever feeling like, I'm not sure what all those things are, go ahead and label them a's, b's, and c's above. Okay, well, obviously to build my frame, I want to know what my starting point is. So starting point, I normally would do C over B for the x-coordinate or the horizontal shifting. What's my value of C? Positive pi over 4. What is my value of B? 1. So that means it's just pi over 4 over 1, which is pi over 4. And then what's my value of D? 0. So I got my starting point. I probably want my period.
2 pi.
2 pi over 1, which is 2 pi. And what was the other thing we used to use to help us build the frame? The amplitude, which I'm not going to write amplitude because it's not an amplitude anymore. So I'm just going to write A equals negative 2. I will use that value to help me build vertically. So now comes the hardest part. Draw a frame. And label. So instead of putting my starting point over there on the left, I'm going to break it up. The x of my starting point, pi fourths, would begin horizontal. And the y of my starting point will begin that middle part of my vertical. Are you okay with that? That's pi over 4, comma 0. Okay. So now I can use my a value of negative 2, absolute value would be 2. From this y value in the middle, which is 0, I should just add 2 and subtract 2. So there is like a vertical stretch, meaning that space in between the u's is now bigger than it was before. It used to just be like a distance of 2 in between the min and max of the u's. Now there's a distance of 4, twice that. And because it's negative, I know I'm going to do a reflected cosecant, so I'm going to put a little. Sometimes I forget about that, so I'm going to put a little note to myself, reflect. Then I started at pi over 4 for my x because I had a horizontal shift, pi over 4 to the right. So to get the rest of my values, I'm going to use my horizontal spacing method. This would be method 2. I'm going to take my period, 2 pi, and divide it evenly by 4. Now that's really pi halves, but because I'm starting at pi fourths, I'm just going to leave it alone because they have common denominators. And then I just start adding 2 pi fourths. So pi fourths plus 2 pi fourths is 3 pi fourths. Plus 2 pi fourths is 5 pi fourths. Then 7 pi fourths, and then 9 pi fourths. That's method 2, just adding a fourth of the distance. If you check your period, like you might have done on your worksheet, 9 pi fourths minus pi fourths is 8 pi fourths, which is 2 pi, which is the period we said it would be.
So do you have to reduce when you like draw a graph if you can or no? Or like the
Yeah, so like if you got like a 6 pi fourths, you could really write that as 3 pi halves. I think some people didn't reduce on their quiz, and I wrote reduce, but I didn't take off for it. Because I mean, 6 pi fourths is 3 pi halves. It's not wrong. But yeah, I would reduce. Okay, so to me, that's the hardest part. The rest of it is just the shape. Okay. Now, I don't memorize cosecant and negative cosecant and secant and negative secant. That's like way too much work for me. So, cosecant is the reciprocal to sine. It's being reflected. So instead of mountain high, valley low, it's going to be valley low, mountain high. Just draw that in lightly. And now I know where to put my asymptotes. Wherever these midline points are, that's when that function equals 0. So I have one at x equals pi fourths, x equals 5 pi fourths, and x equals 9 pi fourths. And then my mountains turn into U's that open up, and my valleys turn into U's that open down. So I have a maximum point here at 3 pi over 4, and this is negative 2. So I label that point. That's easy because I've already done my frame. And I did that one up here. 7 pi fourths and 2. Just make sure when you draw your U's, you keep them within their asymptotes.
If we like add on to the amplitude so we can fit our U's, is that okay?
Yeah. Like within a frame.
Yeah, like if instead of doing 2, you did 4, that way it's still
Yeah.
different.
Sure. Okay, and then last thing I could do now is answer my range. So I'm going to do the range of my U that opens down. Negative infinity to negative 2. Negative infinity to negative 2 included. It'll always be a bracket right there at the top of your U. In union with, now do the range of my U that opens up. 2 to infinity. Got it in. So those of us who feel really confident in sine and cosine, cosecant and secant are going to be easier. If you have to go back and fix some of those things from the quiz, I would do that first. Figure out what you didn't get right on sine and cosine before you do your homework tonight for cosecant and secant. Because you don't want to make mistakes with sine and cosine, then you're going to have problems with cosecant and secant. Okay. Does anybody have any final questions or concerns about cosecant or secant? Okay, now we're going to talk about tangent. Maybe like shake it all off at this point. Take a deep sigh. You're tired. It's the middle of the day. You're going to go to school all week this week.
No.
except for Thursday.
Okay, now I just want to give you, I'm not going to write this down, but I'm going to talk about it. Do you remember all students take calculus? Okay, so I'm going to talk about that for sine. For sine, in quadrant 1, it starts positive, positive, negative, negative. So in order to get like the full wave of sine, you had to go all the way around the circle, 2 pi. That's why its period is 2 pi over b. You got to do positive, positive, negative, negative. When you do cosine, cosine starts positive, negative, negative, positive. So again, you have to do the full rotation to get all the pieces. It goes positive, negative, and then it goes in reverse, negative, positive. Think about that for tangent. Positive, negative, positive, negative. So tangent takes less time to repeat. Positive, negative, it's done. And then positive, negative, it's repeating itself. Instead of having a period of 2 pi, it has a period of pi. Okay. So that's what this unit circle was there to illustrate. And then remember, I kind of showed you an animation for sine and cosine, and it would keep drawing a wave. So like this is part of quadrant 1, this branch right here. And then this is quadrant 2 and quadrant 3 because those are negative, positive. So it starts negative and then it goes into the positives. And then this is quadrant 4 where it's negative again. And we're going to change something about our frame so that instead of doing like this positive and this negative portion from 0 to pi and having it broken up by an asymptote, we're going to put our starting point in the middle of our frame so that we can have one full tangent in the middle here. Okay, so that's going to be a couple of things that are going to be different. I have a little half sheet for you. Olivia and Heidi, if you guys want to go over and grab the tape for your, Trent, you want to grab the tape on my desk?
Yes.
If you want to take this into your notebooks, you can.
No, I don't have it.
We won't graph cotangent. You guys are good sports for doing all these graphs today with asymptotes, so we will only make you do tangent. That's our one nice, well, we do many nice things for you, really. Just don't know it. Okay, so as people are taping, I'm just going to point out a few things. So if you read number 1 is now different. The starting point is still the same, C over B comma D. So don't change anything about how you find starting point, but where you put starting point is different. It's going to be in the center of the frame. So like for the other 4 graphs, you always put your SP over here. For tangent, you're going to put SP in the middle. Okay. The other big change, vertical spacing is still A, is going to be number 3, your period. Instead of doing 2 pi over B when you get to a tangent problem, you need to just do pi over B. Okay, now I'm going to talk more about this in our example, like this horizontal spacing thing. But I'm just going to describe it like this with my little image right here. If your starting point is in the middle of your frame, then we want half the period on the right, and we want half the period on the left, and that makes one whole period when you add them together. Okay. So I'll talk about that in our example, more about the spacing. But of course, you'll label the asymptotes and the critical points. Okay. Make sure that you fill in these 2 pictures for tangent. Your asymptotes are always going to be on the outer part of your frame. Tangent will pass through the starting point of your frame. And when tangent is positive, it's increasing from left to right. When tangent is negative, it's decreasing. And on a side note for anybody who cares, tangent with a negative A is basically cotangent. And tangent with the positive a is basically negative cotangent. I mean, those are the only shapes that you get for tangent. It looks kind of like our cubic function, but of course, after that, asymptote's just going to keep repeating itself. So it's all these like cubic functions next to each other. What would the range of one of those branches of tangent be? Negative infinity to?
Positive infinity.
Positive infinity. So you can write down here that for the range of all tangents, it's negative infinity to infinity. So that's nice. That at least makes it a little bit easier. One part. Okay, so we're going to squeeze in one quick example before we leave. And then, like I said, your homework is like 4 or 5 problems. Then maybe you have to fix sine and cosine on your quiz. So very doable. We're going to do y equals 1/2 tangent x over 3. Okay, well, what's my a value? 1/2. So this is just a positive tangent. I know it's increasing from left to right, and I'm going to use that to build my frame. I'll go up 1/2 and down 1/2. It's fine that it's a fraction. My starting point, what's my c? 0. And my d?
0.
Also 0. Love it. And then for period, remember, be careful. Instead of 2 pi over b, it's just going to be
Pi over b.
pi over b. What is b?
1/3.
1/3. If you have x over 3, that's like 1/3 times x. So that's really pi times 3, which is 3 pi. So this tangent is getting stretched horizontally. It takes 3 times as long for it to complete a period. Draw a frame. It still has 8 panes. Instead of putting 0, 0 on the left side of your frame, put 0, 0 in the middle. Okay, so this is 0 and this is 0. I, of course, creature of habit, I like to do things the same way every time, so I'm going to do my amplitude or do my a value and do my horizontals before I draw the picture. So if my a was 1/2, this is going up 1/2 and down 1/2 from 0, so that would be negative 1/2 to 1/2. And then remember the weird part about putting your starting point in the middle is you want from left to right to be one period of 3 pi. So that means you have to do half of that on both sides. So 0 plus 3 pi, or plus 3 pi over 2, it gets me to 3 pi halves. And minus gets me to negative 3 pi halves. That's like from negative 1.5 to positive 1.5 is a distance of 3. What's in the middle of 0 and 1.5, or 0 and 3 halves?
3 pi over 4.
Yeah, just half it again. So half of 3 halves is 3/4. So we're going to have a 3 pi over 4 and a negative 3 pi over 4. And then I'm ready to sketch tangent. So for tangent, this one's new. I do just like I remember mountain high, valley low, and my ice cream cone. I just remember the way we built this frame was to have asymptotes on the right and the left. So x equals 3 pi halves and x equals negative 3 pi halves. My tangent will go through my starting point, 0, 0. And if it's positive, it's increasing, and if it's negative, it's decreasing. And I'm going to use these points on my frame. Like, if I wanted to transfer this to a coordinate plane, like negative 3 pi fourths, comma negative 1/2, that's an actual point on this tangent function. Like, this works out. So I'm going to actually label those 2 extra points. This one will be 3 pi 4 1/2. And then I just draw that curve. So there's a positive tangent. I've got starting point period. I could add range in there. That's negative infinity to infinity for tangent. But again, I won't ask you about domain because of the asymptotes. Okay, so 4 or 5 problems for required homework tonight. Do those. If you need to or wish to earn any credit back on your quiz, it's 5 required problems, then do those quiz corrections and have those ready. I'm here after school today, and I'm here tomorrow before school in the morning. If you have any questions, please come in and see me. I want to answer those for you. You guys did awesome. Thank you.